Chapter 5, page 11, enantiomeric excess. Now, on the previous page, we saw that we could measure the specific rotation of a molecule, and that's standardizing the conditions that we measured on. And I won't get you to do the calculation for that, but I will get you to do the calculation for enantiomeric excess. So let's go ahead and take a look at it. Now, there are two problems on this page, so I'm going to break this up into a part 1 and a part 2. If you have a 50-50 mix of two different enantiomers, we said that they would cancel each other out and they wouldn't rotate light. But what happens if you don't have a 50-50 mix? If you're working for a pharmaceutical company and you're trying to make a chiral drug, you want to know, did I make just one isomer? Did I make just the other? Did I make a 50-50 mix? Or did I make something that there's more of one than the other? And when you have more of one compound than the other, we say that there is an enantiomeric excess. Now, normally when I would want to explain something like this, I would go to the blackboard and do an extra little section before the problems. So let's go ahead and do that on this extra page. So here is an example problem that goes over the concept of an enantiomeric excess. So let's say I have my sample container right here, and in that sample container I have 80% of the R compound and 20% of the S compound. All right? So I don't have just one pure compound, and I don't have just the other, and I don't have a 50-50 mix where they would cancel each other out. I've got an 80-20 mix. Well, here's what's going to happen. As the light passes through this sample, some of the R compounds will cancel out with some of the S compounds. So an even amount of the R will cancel out with an even amount of the S. And then whatever is left over is what we call the enantiomeric excess. So in this example, I drew 10 little molecules in there, 8 R's and 2 S's. So 80% of my sample is the R and 20 is the S. So 20 of the S's, or 20% of my sample, will cancel out with 20% of the R compounds, leaving me 6 R's here, or 60% of the sample will be in excess. So let's go through some numbers to understand how this works. So if I looked up the specific rotation of just the R compound, I could find out that it rotated light plus 10 degrees. Okay? That means that then the pure S compound would have rotated light minus 10 degrees. The exact same amount, but in the opposite direction. So what will this 80-20 mix rotate light? Well, that's what the enantiomeric excess is. So, if I had the example that I have up here above, then 60% of my sample has an enantiomeric excess of the R compound. The R compound is in excess. 6 out of 10 of my R compounds are in excess, and then 2 of my R's canceled out with 2 of my S's. So that would give me 60% of my sample is still the R. Now, if I know that the pure R compound rotates light plus degrees, then 60% of plus 10 degrees would be plus 6 degrees. And it's no more easier or hard than that. So if you know how much of your sample did not cancel out and which one was in excess, then you multiply that percentage by what the pure compound would have rotated light, and you can figure out what this mixture will do. Now, let me also phrase it this way. If the S compound was in excess, then I would have used this number down here, but that's not what I had in this example. The R compound was in excess. Now that we've walked through that concept, let's go back and do the problem on the previous page. So, example number 1. Let's take a hypothetical compound, and this is not the real numbers for this compound. I'm just going to make this up. So let's say I had this compound right here. I'll put an aldehyde up here. I'll put an alcohol here, a hydrogen, and a CH3. That would be a chiral molecule. And let's say this compound rotates light plus 10 degrees, or dextrorotatory by 10 degrees, if I measured it under standardized conditions. Well, what would happen if I had a 75-25 mixture of 75% of my compound was this compound right here, and 25% of it was the mirror image? Well, here's what I'm going to do. I'm going to say 75% of the plus isomer, and then I'm going to have 25% of the minus isomer. 25 of the minus isomer will cancel out with 25 of the plus isomer, leaving 50% of the plus isomer in excess. Now, these are not plus minus symbols meaning math. They're just dextrorotatory and levorotatory. I could have done D's and L's there. So the enantiomeric excess is 50% of the D isomer. That's a terrible D. Of the plus isomer, or the D isomer is 50% extra. Now, if I know that 100% of this plus isomer rotates light plus 10 degrees, then 50%, or I could say 0.5 times plus 10 degrees would be plus 5 degrees. Again, the pluses and minus are not math operations. They're saying dextrorotatory is the plus and the negative sign is the levorotatory. So, a 75-25 mixture of 75% of this dextrorotatory compound and 25% of the levorotatory compound would have a 50% enantiomeric excess of the dextrorotatory compound, and it would rotate light plus 5 degrees in this example.